Hello students, I am Pawan Kumar, Faculty of Mathematics. Today we are going to study about the trigonometry and basically the basic concepts of trigonometry. We are going to start with the basic concepts and then we will discuss about the some special trigonometric ratios that belongs to the specific angles just like the 30 degree, 45 degree. Okay, so before discussing about the next part, we start the basic concept first. Okay, so firstly, what is trigonometry? What is trigonometry? Trigonometry is basically the study that based on a right angle triangle. It is the study of a triangle that based on basically right angle triangle, study of angle. Okay, and no trigonometry cannot be studied without a right angle triangle. So the first primary condition which is required here, it is to what? It is the right angle triangle. In this triangle, the triangle that I'm drawing right now on the board, you can see this triangle has the angle B as 90 degree. Okay, this is what the angle B is 90 degree. So the side which is found in front of the hypotenuse, it is known as hypotenuse. It is what? It is known as hypotenuse. You can denote it shortly by the capital H. Okay, and one of the important thing I would like to tell you all of you, people think that what the line which is found in horizontal position, that is to be base, and the line which is found in perpendicular condition or in standing position, that would be the perpendicular, but it is wrong. The perpendicular and base are based on the angles that we are drawing in a triangle. For example, a triangle that I already have drawn, and the second one triangle I'm drawing right now, you can see here. The important thing is what we are drawing the triangles in the same conditions, angle triangle ABC and triangle ABC in both of the situation. But the important thing is what one side in the first triangles I drawn the angle theta. This is a simple a representation, just like the zero is to be crossed. Okay, so this is to be this theta is to be denoted at the angle C in the first triangle and theta is denoted at angle A. Okay, so what is the basic difference in between these two triangles? So according to angle theta, we can easily identify the perpendicular and base. So first of all, important thing is what? The line you found in front of 90 degree. The line you found in front of 90 degree. That is what? Hypotenuse. And the second thing is what? Angle theta. Angle theta always enclosed. It is always enclosed in between. It is always enclosed in between base and hypotenuse and hypotenuse. So one of the important thing that you can easily understood what we already have find out the hypotenuse which is found in front of B. So in the first primary case you are seeing in triangle ABC, first triangle ABC. So here the hypotenuse H is equals to what? AC. Okay, and angle theta always enclosed in between the hypotenuse and base. So angle theta enclosed here in the first triangle in which lines? The line AC and line BC. Okay, so AC is already we have written what? That is the hypotenuse. AC is what? Hypotenuse. So the angle enclosed in the second line, which is the BC. So BC is what? BC is base. It can be denoted by the capital B. We have the hypotenuse and base. And the last third side is what? The perpendicular. And perpendicular is what? AB here. Okay, the same thing that you can understood in the second triangle. Here you can see always in front of 90 degree and the longest side of the triangle, longest side of right angle triangle is the hypotenuse. So here AC is the hypotenuse. Here AC is what? Hypotenuse. But the important thing is what? Here angle theta is enclosed in between AC and AB, which is looking like the perpendicular. Okay, but it not actually perpendicular. It is the standing line which enclose the theta and the theta enclosed in between base and hypotenuse. So here AB is equals to what? Base. Can be denoted by capital B. Hypotenuse can be denoted by capital H. And the important thing is what? The remaining side is here BC. And here BC is what? Perpendicular. So I hope you understood well this concept. Now we are going to discuss about the ratio of the angles. Okay. So to discuss about the ratio of the angles, I'm going to tell you the six ratio. Okay. Basically the primary ratios. Primary ratios are what? The sine theta, cos theta, and tan theta. Okay. These are the primary ratios. And if these ratio are to be inversed, means 1 upon sine theta is to be written as the cosec theta, and 1 upon cos theta it is to be written as sec theta, and 1 upon tan theta is what? It is to be known as cot theta. Okay, so these are the three remaining ratios. So firstly, I'm going to discuss, not only we are going to discuss about the sine theta, cos theta, and tan theta, right? So let me start to discuss it with a right angle triangles. Okay, so here I already have drawn a right angle triangles. So its name is what? PQR, where angle Q is equals to what? 90 degree. Now we can draw at any side one angle, but whatever ratio that we are going to draw, that we are going to study, that would be based on that angle. For example, if I draw angle theta at the vertex of R towards the R vertex. So we start to discuss according to vertex R. So you can say what? Angle theta, or you can also pronounce it as angle R. Okay. So both of these two things are same. So what is that? Let me say. So sine theta is always equals to what? Perpendicular. Perpendicular means capital P, perpendicular upon hypotenuse. And the second ratio is what? Cos theta. Cos theta is equals to base upon hypotenuse. The third ratio is what? Tan theta. It can be written two types. Just like first thing is what? It can be written as perpendicular upon base, or you can also write it as what? The sine theta upon cos theta, right? Why? You can ask me later. Okay. Now I'm going to tell you P upon H is the sine theta, B upon H is the cos theta, and P upon B is the tan theta. Okay. So according to this, what we can say now, in the first case, sine theta is perpendicular upon hypotenuse. If our angle is theta, so in front of theta we have what? The perpendicular. So sine theta must be PQ upon PR. Why PR? PR is hypotenuse here. Or if angle is theta at R, so PQ must be the perpendicular. If we would have the angle P, so in front of P, the QR side would be the perpendicular. Okay, but we are going to discuss the angle at R side. So definitely PQ is the perpendicular here. Okay, so PQ upon PR. Then cos theta is equals to base upon hypotenuse. And we already have discussed the theta enclose the two sides. One is base and another is hypotenuse. So base upon hypotenuse means the angle including sides, where hypotenuse, the biggest side of a right angle triangle, it is what? PR here. And base is QR. Then tan theta. Tan theta is what? P upon B, perpendicular upon base. So here perpendicular is PQ and base is QR. So these are the three angle functions which are written according to the ratio of their corresponding sides. Okay. So the next three part can be understood as what? If we very well know, if we very well know the sine theta is equals to perpendicular P is for perpendicular. Perpendicular upon hypotenuse, cos theta can be written as B upon H, means base upon hypotenuse, and tan is to be written as tan theta is what? Perpendicular upon base. So what can you say? What can you say about the inverse of these functions? The inverse of sine theta is what? The cosec theta. So cosec theta is equals to 1 upon sine theta. 1 upon sine theta means 1 upon P upon H. And H is carries toward the upper side, towards the numerator. So definitely it would be what? Hypotenuse upon perpendicular. So this is the simple notation, simple ratio for the cosec theta. It is for what? The cosec theta. Same case, you can say what? For the sec theta. Why? Sec theta is the inverse of the cos theta. So inverse the cos theta means 1 upon base upon hypotenuse. Hypotenuse can is carried toward the upper side with the numerator. So hypotenuse upon base is equals to what? The sec theta. Same case for the cot theta. For the cot theta, you can say what? For the cot theta, it is equals to 1 upon tan theta. It would be equals to what? 1 upon perpendicular upon base, and it finally equals to base upon perpendicular. For which one? It is for the cot theta, right? It is for the cot theta. Now we are going to discuss how these can be used to solve the few questions that are based on the ratio. Okay, so the one important question, it is not only important, but for the start of the these concepts, it is a basic question. Okay, so I'm going to discuss you. If a question is what? Question is given to you if 3 sine theta, if 3, sorry, not sine theta, if 3 tan theta equals to 4, so find out the value of sine theta, cos theta, and the remaining all the ratios. Sine theta, cos theta, tan theta is already we have. Okay, we can write also here the tan theta and the cosec theta, sec theta, and the last one cot theta. How can we write the value of these function? Okay, so theta is same for all. So the first thing is what? The value that we have 3 tan theta is equals to 4. So here 3 in the multiplication, it carry towards the right side. So finally what we have, tan theta is equals to 4 upon 3. Okay, if I draw a triangle and I took an angle to represent, for example, triangle I have ABC, we have triangle ABC, and tan theta we already know what? It is always perpendicular upon base. It is what? Perpendicular upon base. So in front of theta, it is a perpendicular. So 4 represent the value of AB. And 3 is the base. It represents the value of BC. Why it is representing the 3 BC? Because angle enclosing sides are base and hypotenuse. So that must be 3. Using the Pythagoras triplet, you very well know AC square is equals to AB square plus BC square. So you can do what? You can easily find out the value of AC. AC square is equals to 4 square plus 3 square, and AC square is equals to 16 plus 9. Finally, AC square is equals to what? 25. So AC square is equals to 25 can be written as 5 square. Square reduces the square. AC is equals to 5 we have. Okay. So AC can be written as 5 by evaluating these values from the Pythagoras triplet. Okay, so now it is easy to find out the value of other trigonometric ratio. Why? Because sine can be written as what? Perpendicular upon hypotenuse. So there must be perpendicular is what here? 4. So you can say what? Value of sine theta according to perpendicular, it would be the 4 upon hypotenuse is what? 5. Same case for the cos theta. Cos theta is always what? It is base upon hypotenuse. So here what we have for the base, angle enclosing sides 3 upon 5 means hypotenuse as a 5 here. Okay, then tan theta. In case of tan theta, we already have 4 upon 3 means perpendicular upon base. That is what? 4 upon 3. Cosec theta, it is, we know about it. Cosec is just inverse of sine theta. So hypotenuse at the numerator side and perpendicular at the denominator side. So there must be what? 5 upon 4. Same goes for the sec theta. It is the inverse of cos theta. So it must be what? The 5 upon 3. Cot theta is inverse of tan theta. So it is to be written as 3 upon 4. So I hope you understood this concept. Okay, should I move for the next? So the next concept we are going to discuss trigonometric ratio of some specific angles. So now we are going to discuss trigonometric ratios of some specific angles. Actually, you can see what there is a table for the specific angles for the 0 degree, 30 degree, 45 degree, 60 degree, and last 90 degree. Okay, this table is for the sine theta, cos theta, tan theta, and also for the remaining parts are what? Cosec theta, sec theta, and cot theta. Okay, so for the 0 degree, what we have? Sine 0 is 0, sine 30 is 1 upon 2, sine 45 is 1 upon root 2, sine 60 is root 3 upon 2, and sine 90 is 1. You can, if I will try to explain you how this value comes, so maybe there is a requirement of another video. So it is better if you ask, so I can explain you with another, in another video, how to create this table. So basically, I'm going to tell you how to solve the question that based on trigonometry and the remaining portion. Okay, so if you find out the or learn the value of sine, all the values of sine, so it is easy to learn all the values of the remaining functions. For example, I'm going to tell you one more concept that belongs to this case. For example, PQR we have, it is a right angle triangle. If it is a right angle triangle, so there must be one angle is what? 90 degree. So according to angle sum property, what we know? Angle P plus angle Q plus angle R, it is always using the angle sum property in a triangle, always 180 degree. Okay, and the value of Q is what we have? Angle 90 degree. Angle P plus 90 plus angle R is always equals to 180 degree. So angle P plus angle R is to be written as 180 minus 180 minus 90 degree. So angle P plus angle R is equals to 90 degree. It means in a triangle, in a right angle triangles, the angle other than 90 degree, they are always complementary angles. They are always what? Complementary angle. And one of the important thing that I'm going to tell you, if you are using the value of sine p, so there must be the condition that the value of sine p would be equals to the cos complementary of p, and the complementary of p is what we have, means 90 minus p. 90 minus p is equals to what we have, r here. So definitely cos r is equals to sine p. Same case with the other values also, means cos p is equals to sine r. And I hope you will try to find out it yourself. And tan p is equals to, complement of tan is what? Cot r. Say, and vice versa also, means tan r is equals to cot p. So you can easily solve this using this property. So I'm going to tell you the other values of this table now. Okay, so at the 0 degree, sine is 0. So what would be the value of cos theta at 0 degree? Just subtract this value from the 90. 90 minus 0 is what? 90. So the sine 90 would be the cos 0, and it is what? 1 we have. Now for the 30 degree, to find out the value of cos 30, subtract this from 90, subtract this from 90. 90 minus 30 is what? 60. So the value at the sine 60 would be the value at cos 60, cos 30. Sin 60 would match with the cos 30. So sin 60 is what? Root 3 upon 2. It would be equals the same value at cos 30. Sin 45, 90 minus 45 is 45 itself. So these two values are same in cos 45 or sin 45. Then for the cos 60, just subtract the 60 from 90. What we have? 30. So the sin 30 would be the cos 60 and it is equals to 1 upon 2. And cos 90 is what? 90 minus 90 0. So the value at the sin 0 degree would be the value at cos 90. It is what we have? 0. And I already have explained you what? I already have explained you that the tan theta is equals to sin theta upon cos theta. Okay, why? Sin theta can be written as perpendicular upon hypotenuse and cos theta can be written as base upon hypotenuse. So hypotenuse reduced out at the same position. So it is to be written as perpendicular upon base. Okay, so you can divide the sine value by the cos value at the same angle. So you can easily find out the tan theta. So the tan theta for the tan 0 degree, it is the sine 0 degree and divide by cos 0 degree. That will be equals to 0.1 and 0.1 can be written as 0. So the tan 0 is 0. Same case for the tan 30 degree is equals to sine 30 divided by cos 30. Sine 30 is 1 upon 2 and cos 30 is root 3 upon 2. 2 at the same place at the numerator and denominator. So it is to be overall written as 1 upon root 3. So the second value you can write, it would be what? The 1 upon root 3. And the third value 1 upon root 2 and 1 upon root 2 at the both of the two side means at the sine theta also, sine 45 1 upon root 2 and cos 45 is also 1 upon root 2. So both of these two are 1 upon root 2 divided by 1 upon root 2. So there must be 1. And the third must be, if you solve it, the root 3. And the one important thing that I'm going to tell you, if a non-zero number is divided by 0, so it is not defined, infinitive. Okay, so either not defined or infinitive is to be reversed. And the remaining values, you can write it yourself. Okay, you can write it yourself. So just because of the scarcity of time, lack of time, I'm going to explain you the few questions that are belongs to this concept. So here I'm going to tell you the first question, just like the find if a triangle you have, the P, Q and R. Okay, it is 12 and it is what? 13. So they are going to ask you that tan P minus cot R. So do you know, according to tan P is always base upon, tan P is the perpendicular upon base, but cot is what? It is base upon perpendicular. Okay, so tan P, the value of tan ratio is to be written according to the P. If you see the P, so in front of P is to be find out the perpendicular, it would be what? QR. And divide by base is what we have? PQ. But the important concept here is what? Cot R value is what? Base first and then divide by perpendicular. But the reference angle is what? Angle R. So according to angle R, in front of R, it is what? Perpendicular. And QR is the base. So the base is what here? QR. And divide by perpendicular is what? PQ. So what we see? The same value and they are to be subtracted. Okay, just like the 2 minus 2. So finally what we have? The 0 answer. Okay, so this is the concept that we already have understood. And now I'm going to tell and explain you the simple case tan A plus B is equals to root 3 and tan A minus B is equals to what? 1 upon root 3. So they are asking you what? Find out the value of A and B. It is very simple. To find out this case, firstly see what? The root 3. Root 3 comes after what? Angle A plus B is equals to root 3 at the tan 60 degree. Same case, 1 upon root 3 comes at 10, 30 degree. Okay, reduce 10 by 10, 10 by 10. So you get what? A plus B is equals to 60 degree and A minus B is equals to 30 degree. By using the elimination, by using what? By using the elimination, you can easily analyze what? 2A is equals to 60 plus 30 is 90. Finally, A is equals to 45. And if you put this value in any of the equation, so just like A plus B equals to 60, and we replace A by 45 degree. So value of B is equals to what? 60 minus 45. So what you get? B is equals to 15 degree. So I hope you understood well. So the remaining portion that we are going to study in the next class. Okay, bye bye and take care. Please revise the topic and be ready for the next video.